Which reagents will convert toluene to p-bromophenol acetic acid? All right, always good to find your own answer first and then compare to the multiple choice, but this time they're giving us specific reagents here, so let's skim them for a menu of options and make sure we're building with the right pieces. First thing we notice is first step is all the same. That's going to be our electrophilic bromination. That's going to give us our para-bromo-toluene, so that takes care of the first part. Then we see some KMNO4 for carboxylation through oxidation. We see some NBS for vinylic bromination. I see a cyanide for making a nitrile through SN2 attack. Then we see magnesium and carbon dioxide suggesting a Grignard reagent for carboxylation. Okay, so we have a few options. Let's start to piece this together by drawing the structure of our product and our reactants. And right away we notice, okay, we've got that bromine on there, para to our acetic acid group. Great, that's taken care of by step 1 in all our options. So the real question is, how do we go from that methyl group in toluene to that carboxylic acid group in our product? And we'll notice that it's in the acetic acid group, so it's a 2-carbon carboxylic acid, which means we've added a carbon. And right away, I'm honing in on that cyanide ion as a way to get that extra carbon in there. It's not going to be the magnesium and carbon dioxide, even though we typically associate Grignard reagents with adding carbons, because in that case, we're turning our reactant into the Grignard reagent. So that's not going to get us an extra carbon in there. Okay, but our cyanide ion is in step 3 in all of our options. So let's take a look at step 2 and see how we can get ourselves in a position to add that carbon. So in option A, we have KMNO4. That will turn an alkyl chain on a benzene into a carboxylic acid group. But in this case, we have a methyl, and in any case, it's only going to be at that first carbon right off the benzene. And so that's not enough carbons. That's a 1-carbon carboxylic acid group. We need a 2-carbon carboxylic acid group. And then even having the cyanide in step 3 in option A still doesn't help us. It's just going to act as a base and deprotonate that carboxylic acid instead of adding the carbon. So A's out, that's no good. Okay, but let's take a look at MBS. That's our N-bromosuccinimide. That's going to give us vinylic bromination. That's going to add the bromine right to the methyl group. And that's actually great because now we have an alkyl halide, and alkyl halides are subject to SN2 attack by nucleophiles, which we have a great one right there, our cyanide ion. So the cyanide ion can come in, do that SN2 attack, and take the bromine's place. Now we have a 2-carbon chain and a nitrile, and if I take that nitrile and I subject it to an acid workup, it's going to hydrolyze into a carboxylic acid, and that will give me my 2-carbon carboxylic acid. That means the answer is C. If this was helpful, be sure to follow for more tips and tricks.